So let's try and understand the input activity. So we click on the input activity. So we are going to know every tools around this activity, and then understand it, understand their functions. So let's get started, and let's look at the bottom two. So we have the first one, and the first one is called the automatic error corrector. So we can put maybe a kind of error in our work. So what we need to do is we click on automatic error corrector, and the errors will vanish. We can also return it. Maybe we want to view the error, so we click and then we check on the error, and then we read it. A non-numerical coordinate found at nothing. Coordinate must be numerical, telling us to check at line 5. So we can click on that to check at line 5. And also we can correct it here. So we click on the button correct automatically, so and it can be corrected. So the second one is formatter. Maybe we have a kind of unorganized environment, unorganized data, or maybe something like this. So we can click on the formatter. Once we click on it, we format our data to be presentable. We have our undo, and then we have our redo. So anytime we try and go to the previous record or to the next record, so that's a function of undo. So we can also hold it, and then we can also hold it. So if you want it to be fast, you have your zoom, and then you have your zoom. Okay, so we have your automatic error corrector. Or what's the function of automatic? Sorry, we have the automatic scaling. What's the function of automatic scaling? Is to make sure it scales the transverse so that the transverse will not be too congested, or it will not be so large, and that will produce a big large drawing. So what it does is to make sure it produce a scale or generate a scale that can make the transverse to fit the screen. So let's try and do kind of experiment with automatic scaling. So let's try and put something like a 9 here. So and then we put automatic scaling to be off. So it means that it's going to maintain the original scale. So we try to plot. So as you can see, let's try and check the scale. So our original scale is 500. So let's go back, and then I try and put automatic scaling to be on. Right now automatic scaling is on, and then the same coordinate, which is 94, we are going to upload and see whether there is a change in our scale or not. So let's click on the scale. So as you can see, the scale has changed. So it means that coordinate plot generates scales for you with the main purpose that the transverse is not too large or too congested, so making it fit to the screen. So let's go back to the input activity, and then the other one below, we have the COR, and it's changing bearings to coordinates already. These are coordinates, so we can go straight to BRG. So click on the BRG anytime we want to change coordinates to bearing. So let's click on that COR, changing bearings to coordinates, and then click on BRG, changing coordinates to bearing. So let me explain this. This is the reference coordinate. Remember, anytime you are using bearings and distances to draw a transverse, you must have a reference point, and that's the coordinate. So being the reference point is written, and then we have others are bearings and distances. So remember I told you you must have your transverse name, and that is the transverse one. And then when you come here, we use semicolon to demarcate this data. So what's the meaning? It means this is true. It means the bearings and distance started from line 2 of this transverse one. So let's read it. Line 1, line 2. So that's the meaning of these two. And then another demarcation, then we reach to 5. It means that the bearings and distance ends at line 5 of this transverse. So let's read it. Line 1, line 2, line 3, line 4, and line 5. So when you're reading it, please don't come here and start counting line 1, line 2. No, you count from the transverse. So let's say this is the transverse, and then we start counting line 1, line 2, line 3, line 4, and line 5. So from 2, which we have seen, and then to 5, and then to this 5. So it's just trying to indicate where the bearings and distances started and then and ends. So it's just very simple. So we can also try to convert to degree, minutes, and seconds. Already these bearings are in degree, minutes, and seconds, so we skip and go to DEC. So we convert to decimal degree, so we click on dec, so we have decimal degree. If we want to return to degree, minutes, seconds, we click on DMS, return to degree, minutes, and seconds. So if we want to work with reduced bearings, so we click on RB. So remember, showing the cardinal directions and cardinal signs. If we want to return to the whole circle bearing, we click on WCB. So return to whole circle bearing. So we have other tools like we have the GPS or the GNS. Sorry, the GNSS. So these are the environments. We are going to learn it later. So we also have the plus size, in case if you want to say the plus size already, the plus size has been set. So we have 50 by 100. That's my own measurement. You have your own measurement. So as you are imputing the dimension, that's for the length and the width, is calculating immediately. So it's being measured in feet here. So I put where you have your own location, and also how you do measure in that location. So once you finish, you can also put add, and you want to add it, and then you can also remove. That's all. Then if you want to get the data, you click on OK. So we need to compute and see what we have done. We can also click on information and then see also our input details. So let's compute. So it's trying to tell us that our transverse are different. So let's try and check why. Maybe we can change this to coordinates, and we click on COR. So if you look at here, this is 0.712 and this is 0.713. So it means a kind of difference in coordinates. So let me explain this. If you look at here, this means that the transverse started from 4774 and then comes to 4771, comes to 4772, comes to 4773, and then the transverse closed back to 4774. It means that we need to copy this, and then once we copy, we come back and then we duplicate. Well, if you look at here, the transverse didn't close very well. Why? Because this differs. So it's trying to tell us that we kind of have a misclosure, and we want to employ bodish adjustment. So you can click on turn on and then you adjust. So this is how it look. The error will be shown, correction error, and then the adjustment. So you are going to enjoy your app as you compute. So we need to go back, and you can also replace what you've got. Remember, this, you click on replace, so exactly it has replaced the old coordinate with the adjusted one. So we can also plot now. So let's go back and plot. But I just want to explain something. Remember, you have your comma sign here. It's just a demarcator, demarcating the point from the eastern coordinates and from the northern coordinate. Remember, the space, it doesn't matter. So you can also try to maybe do something like this. It doesn't matter the space, but the reason why coordinate plus always want to show the space is just for presentation sake. That's why we have the formatter where we format. So you can also try to shrink your own. As far as you put your comma signs, there must be two demarcating the points, and then the easting, and then the northing. So let's plot. So alright, so this is our plotting. We can also go back to original plotting, so we can come here and try to change this to 64, and that's for original plotting. We can get it, or maybe it's not even our original plot, but we have something like that. Maybe it should be 554. So let's check on here. We have the original plotting. I guess I was mistaken. I thought it was 64, but never knew that it was 74. So that's it, and that's how all about working with the NP environment.